Can you hear the audio now? Is everything working again? Just quickly say in the chat yes or no. Yes, if you can hear me. Yep. Yep. What's going on here? Top. Okay, great, wonderful. So then I can start from the beginning again. I have no idea why, but for some reason OBS threw away my presets. Great. Okay, but now actually there are some people. In the stream, so it makes sense that I start new. Last time I took several of my Zettels, and I'm not gonna search for them now, where I had some of the models that other people had put forward how we sense touch, how we can localize touch, and I tried to integrate them. You see the little boxes, and it's a bit unclear. I think now it should be you should just be able to read it now. It says tactile efference here and proprioceptive efference. Efference is what goes towards the brain, efference with an A, and efference with an E is what goes away from the brain. Tactile just means the sense of touch, and proprioceptive efference. Proprioception means the angle of our joints, how tense or relaxed our muscles are, and so on. Whereas the efferent commands, these are the commands that the brain sends to the muscles, but they also get fed back into the sensory system as inputs. So efferent commands are also inputs, and then we have visual information as well, if that is available. And from there, the information flows to several other, where they are not really areas, they are functions here. And I try to integrate that. Great, and basically all of that is the perception part. And as I was drawing that, I realized certain of those things can be clustered as inputs. So I did this here, I wrote inputs. And then we have the action towards the touch. So we have the perception and we have the action. And then at the very end, I actually came up with a sort of a more refined series of steps that I want to work on next. And I framed them as questions. Is the assignment Longo Heat correct? So Longo was the main author of one of the papers, and Heat was the main author on the other one. Is my integration that I try to do, is that correct? How many integration steps are there? That has to do with the boxes. What is somatic touch localization? Oh, that's just this box here. It says somatic touch localization, and I forgot what it meant. How does this fit with experimental evidence? Now, before I really go any further here, I would like to continue with something else. Boop. This is my logbook, my notebook. Specifically, I want to continue with this ABC active that I've done here, and you can't really read this. Right, but this is a paper that I'm currently reading, Computational Elements of Natural Vision, that's it, of natural vision, which I find very interesting, and which I think, even though this is about vision, not about touch, I find it fits quite well in what I'm doing. So I would like to think more about this, and that's what I'm going to do today. So just to show you what I am, or how I what I'm doing as I'm reading and as I'm taking notes. disregard this. This is just an ABC list where I'm brainstorming something. But here, this is my ABC active. And can you see that about sort of almost? You can probably not read my handwriting. But this is the ABC active that I'm creating as I'm reading the paper. I haven't finished reading the paper and I haven't colored anything yet. I haven't started categorizing any words. But I write down sometimes individual words or sometimes small expressions like a long time frame, which means that in natural vision or in anything we do naturally, usually we have a time frame of at least several minutes as we explore something, whereas in most experiments we only have maybe a split seconds or a couple of seconds. And what the authors argue for is that with that type of experiment we can't really find out what we do in a natural environment. Others are like uncertainty. That means the uncertainty in our inputs, the uncertainty in the perception, the uncertainty in the motor output. Sometimes it's just individual words, but they are written down here. And then you see I have some, I have already prepared more for other things I'm going to read. What I have in addition is sometimes I have some ideas as I'm reading, more than what I can put into the ABC list in the ABC active, and then I write or draw or think about this, putting away the paper for a moment, think about this, then get back to the paper so that I don't lose that idea. And what I done first here, it says natural vision. I just drew a little CaGa to express one of the ideas of the paper. And that is that if the ground over which we're going is smooth, then we're usually looking very far ahead. So here you have the smooth ground, here you have a very simple stick figure walking, and here you have a dotted line showing this figure is looking far ahead. And we're only looking sometimes, and we can plan very well. But as the roughness of the terrain increases, which is represented here by this squiggly line, then we're looking much closer to where we are now, again represented by the dotted line. And also we're looking more often. And what that means is, what this seems to indicate is that there is some working memory or some memory bottleneck. And so we need to look more often to remind us what's there. We can't plan so far in advance. And then this arrow here suggests the transition from one to the others. So this is technically all of this is one CaGa made up of two smaller CaGas. And then I wrote down a little question like, is there a continuous reduction of gaze length with roughness, or is it, I called it saltatory. What I mean is, are there jumps? Like if the roughness increases to one spot, we're looking that far ahead, and then suddenly it jumps to we're looking that far ahead, something like that. And then I wrote down a couple of ideas regarding perception and action. And especially going back to my peripheral nerve repair patients. And as I was reading more, as I was thinking more about this, I wrote again something about working memory and impairment. And this is precisely what I would like to think about today. I don't know yet exactly what I'm going to do, but I will decide in a moment. For now, however, let's remove this slide so we have a blank canvas to work on. And I think I might actually start with an ABC list just to see what's coming to my mind. Sorry, let me quickly draw the alphabet: A, B, C, D, E, F, G. HIJKLNOPQRSTUVWXYZ. Yes, even I can say my ABCs. So the topic, that's the question. What should I choose as a topic? Do I want to choose working memory and impairment maybe? Natural vision, action. Actually, when I look at this here, oops, something came to my mind, and especially that this interaction between perception and the action towards the touch is very similar to what's the name, Rothkopf and I can't even read my own handwriting, but what the authors of that paper are talking about. So should I? Let's actually call it natural action or something like that. Natural action, and then that's maybe a tiny bit too small for you. Let me see whether I can go closer. That is about as close as I can go. It's still not very big, but let's brainstorm some ideas I have. And I will talk the whole time as I do the ABC. That's of course not what I do usually, and then I will talk about it later. So one of that was the things are working memory. We have PNR, patience, then we have strange sensations, and I will say something about that later. Strange sensations, working memory, what else? So we have action, we have rewards, and we have risks, and we have certain costs and trade-offs, Yes. Anything else that comes to my mind? Let my eye wander over the letters. Something with F, E. What else? PNR, patience. Maybe I should have vision and touch. Maybe I even should have remapping. I have remapping. Then what else do I have? What else do I? Maybe I should put objective as well. Yes, objective. I should probably put recognition. Mental model. Good. Noise, yes, noise. That's actually one of the most important things. Noise, uncertainty, noise. Yeah, I think this is all for now. Let me stop here. And then, good. So, why did I write down what I wrote down? Well, the action, I already talked about this. The authors of the paper make quite an argument that you can't study perception by itself, but you need to take into account action. Perception serves some purpose. Usually some action purpose, of course. I wanted to say especially in humans, but I guess I can't say that because I don't know about other animals enough. But yeah, it can also, in humans, it can also serve other purposes, for planning purposes, for teaching other people, for talking together, communicating, and all of that. But in the end, there's always some sort of action associated with it. Then the next one is costs, and that goes together with rewards. If I want to do something, if I want, for instance, I want to slide this pen, or I want to push the pen, I want to roll it, and it should land at the letter A. If it lands close to the letter A, I get a reward. Either I get a real reward, somebody praises me, somebody gives me some money, whatever, or at least I feel good because I achieved my goal. Potentially the reward can also be more important, of course. It can mean that I get food, I get a shelter, I get out of the rain, not by sliding the pen, but other actions could have these rewards. And if I roll them too far, there is a potential cost, at least the psychological costs, in that I'm not really, that I didn't meet my goal, but the cost could be much more severe. In the most severe situations, the cost could actually be the loss of my life, or the loss of the life of somebody from my group. And of course, most costs, they are much smaller. If I want to pick up the pen, one of the costs, or the cost is if I don't do it correctly, I drop the pen. And maybe it's very hard for me to pick up the pen. Why do I choose that as an example? Because that is exactly what I found with a lot of the patients that I tested during my PhD. And that's why I wrote down the PNR patients. PNR stands for peripheral nerve repair. So just as a reminder, I think I mentioned that every time in all of my live streams. But essentially, what I looked at during my PhD were people who had an injury after an accident of one of their major hand nerves, and these hand nerves then need to be repaired surgically. And so these are peripheral nerves. The central nerves would be the brain and the spine. So these are peripheral nerves. They have to be repaired, peripheral nerve repair patients, PNR. So there was cost and rewards. Risk is also, if I don't do it correctly, there is a risk associated with it. I'm not quite sure whether that would be the same as costs or whether these are two different things. And there is a trade-off with all of the actions we do. There is a trade-off associated with it. If I go back to the rolling my pen, if I roll it too far, oops, I can't even do it if I wanted. If I roll it too far and it rolls off the paper, that is not good. So I might potentially want to reduce the amount of force I use. But if I don't push it hard enough, I can't do it on purpose. If I don't push it hard enough, then it doesn't go to the level A. Or if I go back to the example from the paper, the trade-off is if I'm looking further ahead, I can plan better, and that means I can choose a route that is more optimized. I don't need so much energy. However, if the surface is rough and I look far ahead to plan ahead, the risk and the potential cost is that I might stumble, I might fall, I might injure myself, or actually I might not choose the most energy efficient route, because as I'm moving forward, I'm seeing the scene from different angles, and I might see there is a better route than what I previously thought. And this is a trade-off I need to make. How far do I look ahead? Do I look ahead more, or do I look closer to where I'm stepping? Do I change, or do I look more often? Do I look less often? These are trade-offs, and there are, of course, energy benefits or energy costs related to that. So these are the trade-offs. Touch is, again, because I'm mainly interested in touch. Not that I'm not interested in vision, but touch is my background, so this is where I have most experience, most knowledge. I go to strange sensations later. Remapping, this is what I talked about last time, that there seems to be what we feel on our skin and what we see with our eyes. There seems to be a mapping between the two. The brain seems to be able to equate it, especially if I'm touched somewhere on the hand. I can imagine where the touch has occurred even if I just feel it. So there's some remapping there, and I think that remapping plays a role in all of that. Recognition, that has to do with action, that sometimes we don't want to carry out an action, but we want, the recognition is the important part. And even if I carry out something like picking up a pen with my eyes closed, I need to recognize that what I'm touching is actually the pen and not something else. So recognition is also part of the action. It's a very important part. It's actually a very important part of the perception. Not only where have I been touched, but also what have I touched. And you can imagine that what you touch can very clearly influence your action. Imagine you putting your hand into a box. You can't see what's inside the box. You don't know what's inside the box. You might maybe you want to pick up a nut or whatever from the box, and suddenly your hand touches something hairy that isn't supposed to be there. Most likely you abandon your goal of picking up the nut for now and very quickly draw back your hand and first try to ascertain what it is that you just touched and whether it's harmless or not. And you're probably very tempted to do that even if you know that there's nothing harmful in the box. So recognition is a very important part of the whole action and the whole perception. Where have I been touched, but also what have I touched? We have a mental model. We have a mental model about the world. We have a mental model about our body, where our body is in space, how big our body is, but also we have a mental model of how things behave. If I roll the pen, the better my mental model is, and the better my perception is, the more accurate I can roll the pen. But for that, I need to have something of a physics model of how the pen might roll. So we have mental model, noise, I come back to that in a moment. Objectives, this is what do I want to do, and I can change the objectives. I have vision and touch. Cool, now working memory, strange sensation and noise. One thing that we don't usually recognize is that all our perception is noisy. We don't recognize it because our brain is very good at filtering out the noise and creating a reality for us. A reality that does not exist in this way. I don't want to go to the extreme of the, is it the structuralists, post-structuralists, or postmodernists, where they say there's no reality outside of our mind. I think there is a reality, and this is precisely why we can perceive it. We can perceive the regularities, but all measurement is noisy. Whether it's in engineering or whether it's in biology, all measurements is noisy. When I touch myself in this case, but if I touch the skin, how the skin deforms is not the same every time I touch myself. Even if I chose exactly the same position every time, the way my skin deforms will be slightly different. The way my neurons react will be slightly different. Let me take what I did 2 sessions ago as a reminder. If this is our skin, these lines here represent different layers of our skin, and these blobs or circles represent nerve cells. As the skin is deflected, those nerve cells react, and then they send signals to the brain via these axons here, via these little squiggly lines. But for the same deformation of the skin, the response of the receptors will not be the same every time. There will be a spread. It will be noisy. How the skin deforms will be noisy. How the receptors perceive will be noisy. Also, the processing in the brain will also be noisy. There's noise all the way along the chain. And not only on the perception, also when I'm carrying out the action, this is also noisy. I won't be able to carry out the action exactly the same every time. If I'm very good at what I'm doing, then the noise of my action will be very small. If I'm a beginner, then the noise will be very large. The same if I know something well. If I'm very good at recognizing certain objects just by touch, and you can train it. Of course, if you lose your eyesight, over time you can become better at recognizing objects. You might also train it for other purposes, or there might be certain objects that you're always interacting with, and you might be very good at recognizing those. Then the noise of the perception will also be smaller. And noise is especially important when it comes to the patients. And this is where we get to strange sensations. What a lot of our patients, or the patients that I tested, actually reported was where since, or let me start a different way. Right after the injury, they can't feel anything anymore because the neurons have been cut. There is no information getting from the hand or from whatever part of the body. In my case, in the case of my patient, it was the hand. There's no information coming from the hand to the brain anymore. Then the neurons are repaired surgically, but that essentially just means you wrap something around the neuron tube, and then the neurons need to regrow. And as they regrow, slowly the perception comes back. Usually it starts coming back from the wrist, and then the further away from the wrist you are, the sort of closer to the fingertips you get, the later it comes back. As a general rule. Of course, even that is noisy. But what people report after their sensation has come back is the sensation is strange. And many of our patients have used the word strange. They can't really describe the strangeness. It's just not how it's supposed to feel. Sometimes they can, if they are touched in one location, they can feel the touch in several locations at the same time. Sometimes if you deliver a point stimulus, they feel an area being touched. Sometimes they can name this, but it's strange in other ways as well. It just doesn't feel as it's supposed to feel. And it also seems to appear as if several touch sensations, like real touch, brushing, and so on, as if they are mixed together. Together with that, there's also a lot of pain, unfortunately, for a lot of those patients. And so the patients, they have a lot of strange sensations, which seems to indicate that it's very noisy, that for them the perception is much noisier than for healthy individuals. Good, and this is actually, let me start with putting some colors to this. So I put noise and strange sensation in red. These are sort of like the most important things. Oh, I need to buy new colors, it seems. I'm running out of, this one is running out. So strange sensations. What I'm interested in is in how far or how do we still perceive under noise. But, oh yes, and I forgot the working memory. So the working memory is that potentially for those patients, the simple fact that the perception is so noisy means that they now have a memory bottleneck where healthy individuals would not have a memory bottleneck. And that this, apart from everything that's going on in the hand as well, that this attention bottleneck might mean that just because of that they are worse than healthy controls, or they're impaired compared to what their performance was before the injury. Good. Noise and strange sensation and working memory. Right. Let's put some more colors to this. Let's say reward and risk and costs. All of those belong to one group, and this is what I got now new from the new paper, which I need to integrate into my model of touch or of perception in general. Then we have action and recognition patterning together, because, and I actually put objective there as well, because that is why we really need the perception and what are we using the perception for. Great. Now, trade-offs belongs to rewards and risks and all of that. Here are my trade-offs. Here are my trade-offs. Then I put vision and touch into one category, and what else do I want to put in there? Actually, let me put PNR patients to strange sensations. Do I want to put working memory into a group of its own, or do I want to cluster it with noise and strange sensations? Not sure yet. But also, so we have vision and touch, and I think I will put remapping and the mental model as well. Yeah, let's put working memory to that, to strange sensations and noise. Oh, actually, this, I don't know. No, I don't. Oh god, I'm going back and forth on this. But yeah, this is, I'm exploring it now, and it doesn't feel right there. So let me try to see. Once we have objective. We have objective, and I pattern objective with recognition and action. Yes. So this is definitely one big component, the objective. And what else? Noise is another big component. So we want to do something, but we can't be certain what we're doing because of noise. There's something that I want to so let's put action here. This is not exactly how I clustered it before, but from objective we go to action. Which means because we have an objective, this is what causes us to take an action. However, this transformation from objective to action, that transformation And let me put a lightning bolt here. There's something getting into the way. And what's getting into the way is the noise. So in other words, the translation from action from objective to action, the action, essentially we don't do what we intend to do because of the noise. Put it like that. Great. Now, so far, so not very interesting. Let me put the memory here as well. Memory, I guess, also impacts that. Yes. I'm just warming up what my thoughts before were. I'm not getting any further than that. Let me see what I wrote yesterday. Yesterday? No, 2 days ago. So, perception action. PNR patients have problems carrying out everyday tasks. That's clearly an impairment in action, but they mostly do not have motion disorders as such. Instead, it seems mostly a consequence of impaired perception. But how? This is a question we have not yet touched at. It's clear that their perception is more uncertain. We can measure this with touch localization, but how does this impact action? What can the brain compensate and where does it start to have problems? For that, it has problems to PNR patients is evident. What costs? Okay. No. I really need to think. This is the whole crux. This is actually precisely what I want to get at. This is precisely what I want to get at, and apparently it is not yet very clear in my mind. So what I've done here is essentially I restated what I just wrote to you, what I just read to you, apologies, what I just read to you, just in a different form. Objective action, noise, memory. So memory, something, actually let me talk about something completely different for a moment, which I think, however, has some bearing on what's going on. Let me talk about expertise, because I just had an association and I think this is important. Expertise. You might not have heard about this, but there is an area of research, researching expertise, and they started with researching chess players. This is supposed to be a chessboard, so we have some black fields and some white fields. Great, so these are the black fields, and on those fields we have some chess figures. We have a pawn, we have let's say this is the king, and bishop and whatnot. How do you draw the bishop? Something like that, maybe. So anyway, the researchers, they put chess figures on the board, and they gave participants a very small amount of time to memorize that. Something like a few seconds, 2 seconds if I remember correctly, or maybe even less than that. So they had a couple of chess figures, unveiled the chessboard, 2 seconds later closed the chessboard again, gave them a new chessboard, an empty chessboard, and said, please reconstruct what you just saw on the other board. And what they found is that I don't want to say professional chess players, but good chess players, advanced chess players, that's the word I was looking for. Advanced chess players, they are much better at this than beginners. And the better you get, the better your chess skill is, the better you are at doing this experiment, or it's reconstructing what's on the chessboard. And they cannot only remember larger configurations of chess pieces. What they can also remember is they can remember them in a shorter time frame. And when the researchers looked at how are they reconstructed, they found that those advanced chess players, they seem to always reconstruct certain groups of chess figures. Yeah, not only individual pieces like the beginners. Maybe the pawn was over here and maybe the queen was over here. No, they're like, okay, tap tap tap, 3 pieces set, tap tap tap, another 3 pieces set, something like that. Then the researchers did something interesting. And they put the chess pieces in a way how they would never appear in a real chess game. And what would you know? With that change, the advanced chess players did not perform any better than beginners. Which means that it's what the advanced chess players were relying on, maybe without even being aware of that, is specific configurations that appear in games. So essentially they did what is known as chunking. Chunking. You might have heard about the very famous paper, the magical number 7 plus or minus 2, or if you haven't heard the number, if you've been into learning or memory or any of that, you probably heard that we can't remember more than 7 things at the same time. That comes from this paper, the magical number 7 plus or minus 2. However, it is very often told in a wrong way, because while it's true that we cannot remember, well, it depends always on the circumstances, it depends on the person, it depends on a lot of things, but roughly somewhere in between 5 and 10, or maybe sometimes 4 or sometimes 11 pieces of information we can't hold in memory at any one time. But these pieces of information do not need to be individual pieces of information. They can also be chunks of information, and you can create chunks of chunks. So you can create, with chunking you have, in this case you have constellations. And what are constellations? Constellations are specific configurations that can appear in a game. And then the constellations are made up of figures. And now you can hold in your mind somewhere between 5 and 9 constellations. And you can tap into these constellations to remember what figures are in them and where are the figures on the board. And you can move from one to the others and back again. And you don't only need to have 2 levels, you can have multiple levels. So you can have something like that. There's probably some limit, but for all intents and purposes, at least from what I know, they can become arbitrarily large. At least we haven't well, maybe we have discovered, I don't know. That's not an area of literature I'm very familiar with. Right, so why did I say all of that? That gave me some idea. That gave me some idea for this bit here. Yes, because that has to do with memory and structure. Memory and structure. I really don't know where this will be going. Memory and structure. If we have a memory overload, no, not an overload, a memory bottleneck. We can overcome a memory bottleneck by chunking. We can overcome a memory bottleneck by chunking. Hey, 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 hey. Actually, let me write this down as a text. Potentially PNR patients have a memory bottleneck. Yes, so let me write this again. Memory bottleneck. Where does the memory bottleneck come from? The memory bottleneck could come from several locations. One of them is a sensory overload. The other one is apologies. The other one is that let's call it chunking mechanism. I don't like that term, but I can't think of any better right now. Chunking mechanism is impaired. Why could the chunking mechanism be impaired? It could be impaired because the sensation could be too noisy. The chunking sensation could be too noisy. Why could there be a sensory overload? Essentially because potentially they can't ability to suppress irrelevant stimuli impaired. And why? Maybe, and I draw this with a dotted arrow, maybe again because the sensation is too noisy. Something like that. I don't know how that sounds to anybody who is listening right now, but I can tell you how it feels for me. For me, it feels like I'm still scratching the surface. I can definitely feel that there is something, but I cannot express it yet. I cannot drill into that. It's sort of, yes, this is what I want to express, but it's also not what I want to express. It's sort of like, I already knew this before. It's not really getting me any further, and this is where the situation that I'm currently at. This is the situation I'm currently at, and I think the only way past that is reading more, thinking more about it, and maybe potentially at some point breaking through it and see how I can do it in a more meaningful way. And also I can feel that this is definitely related to the model that I drew up the last time, but I don't know how. And it's also related to what I found newly due to my new reading, with the trade-offs and the costs and the risks, and that we have some sort of, that we potentially, that's the hypothesis, that's the theory maybe, theory in a scientific sense, of course, I don't mean speculation, that when we're planning our action, we're taking these risks and costs and rewards into consideration, and somewhere there I can feel there is a union waiting to be uncovered, but I can't really express it right now. I can sort of not really see it in my mind's eye. I can feel it in my mind's eye, if that makes sense, but I can't see it clearly enough to express it. That's the situation I'm currently at. Oh, not a very nice feeling. Maybe I can definitely see why some people might like to avoid this feeling, but I absolutely love it. This exploring a new paths and sort of seeing charting a new territory that hasn't been seen before. This is very exciting for me, but it can also be very frustrating. Okay, I have a few people viewing right now. Maybe so far there are no comments in the chat that I can see, but maybe you have some comments, questions, suggestions or something else. Then maybe now is a good point to ask them about what I said or about the tools I used or whatever. I think there's a bit of a lag. Maybe you already typed your question, but then it takes a couple of seconds before I can see it. Or maybe you're still typing or you're not sure whether you type. In case you need more time, I just continue talking for a little bit. Yes, so this chunking is definitely related to the memory. I feel that I can't get any further today, but I want to look one thing up. What do I want to look up? And please feel free to ask any questions or any comment you might have. Am I too far already? Yes, perception. Circular processes create order. That is not what I want. Touch of efference. There we go. Yep, that's what I wanted. I wanted precisely this zettel here. Because on this zettel, and I mentioned that before, this gives us some mechanistic explanation on how the brain potentially corrects for noise. And the question now is, why does it work in healthy individuals and why does it break down in patients, and at which point does it also break down in healthy individuals? Okay, but we have a question. Have you seen the impact of memory and understanding from brain injuries versus PNR? I personally haven't yet researched brain injuries, and I have to admit that I'm not very... I don't know a lot about that. I don't know a lot about that literature. But with brain injuries, that's really when, as the name implies, that your brain is injured, and then of course, and sorry, just to be absolutely clear before I say anything, I am now speculating based on my knowledge. My speculation might be wrong, just so that you know how to interpret what I'm saying. But yeah, because the brain is damaged, that can of course also damage areas in the brain that are responsible for memory. And with brain damaged individuals, I know that much, you very often see movement impairments that have nothing to do with perception, but they're simply not able to carry out the motion. Maybe they are shaking uncontrollable, have some tremor. Maybe they don't have strength anymore, something like that. Maybe they can't follow a straight line anymore, and if they want to go that way, they sort of wheel their way that way. But that is because their brain is really damaged, and it is damaged to such an extent. Sorry, one of my alarm clocks is going off right now. I don't know whether you can hear this. Just one moment. Great. Didn't plan this through. So the brain is really damaged, and to such an extent that it can't be compensated for. With peripheral nerve injury, we have a different situation. The brain itself is not damaged. There are some changes to the brain. We know most of that from animal literature, a little bit from humans, but there are some changes to the brain which seems to be because something changes in the periphery, also something seems to change in the brain. But the impact of those changes, they are absolutely not understood at all at the moment. I have to say. There are some speculations, there are some hypotheses, but I think they are, yeah, we're not good at that. So, but getting back to memory. So that means for peripheral nerve repair patients, PNR patients, the memory itself is not impacted. Well, what could happen is that because of the strange sensations that I talked about before, you can get an influx of information at the same time. And what we don't realize usually is that we have a attentional bottleneck and the memory bottleneck in the brain. So we get a huge, and I mean ginormous amount of information at any given time from all our senses. From our eyes, from our skin, from our ears, noses, our temperature sensor. It is mind-boggling. And one of the major responsibilities of the early parts of processing is to wiggle this down to just a tiny stream of information. And that information is then processed further downstream in other brain regions, and that's what we use for planning. And of course, that focus, that can change. We can focus on this one now, this one on the other. And it can be, and now I'm again speculating, it can be that because of the strange sensations so much, and because of the repair, so much is going on that usually was not going on before the injury, that the brain does not have a mechanism to cope with this, and you simply overload the filter. Another option is that because of the secondary changes that happen in the brain, because of that, there's something that this mechanism here changes and no longer works as well as before. Maybe this is impaired. Maybe the inputs just got more than they were before. And so these are speculations. These are very important speculations, and I think it is very important to convert them into predictions and predictable or testable and falsifiable predictions that can then be tested in experiments. But yeah, this is a very good question, and one of which I don't have a good answer for at the moment, because for one, because I need to read more in some parts of the literature, and for another, because we don't really know a lot about right now. Does that answer the question at least as far as I can at the moment, or did I go and drift into a completely different direction and you meant something else when asking the question? So, very interesting area. Yes, I agree with you totally. It was an absolute stroke of luck. When I first saw the PhD project advertised, I didn't know it yet, but the more I get into this area, the more interesting it becomes. It's absolutely fascinating. Okay, I'm already over the hour. Apologies. And as you can hear from my coughing, I also need to give my voice a rest now. This is why I'd say I will cut it here, and I will be live on air again next week, same time. And then let's see where my exploration will lead me that time, and what areas I'll be exploring, what I've read by that time, and I will meander myself more deeper into the topic, and hopefully over time I will be able to develop the thoughts and be able to express them more clearly and translate them into proper experiments. So thanks everybody who watched live, and of course also later anybody who watched the recording. If you have any more questions, don't hesitate to ask them in the comment section. If you found the video useful, please don't forget the like button to give. I can't really talk anymore. If you found the video useful, please don't forget to give the like button a high five. Consider subscribing if you haven't already. And until next time, keep thinking.